I'm a firm believer that security in general, especially on Kubernetes, is enough content to literally create multiple books, multiple courses, and a million and one other things to be able to teach this topic. However, we do only have a few minutes here. So in this video, what we're going to do is we're going to talk a little bit about the core basics around securing Kubernetes on OpenStack. And we're going to go through a little bit of a PowerPoint, just, get the theory down. And then what I'm going to do is I'm going to show the OpenStack console running on OpenMetal. That way you can get a little bit of an idea from a hands-on perspective of what these things ultimately look like. So when it comes to Kubernetes, especially on OpenStack, there are two sides of security. There's the dev side and there's the ops side. Now, for the people that are most likely watching this video, and for everybody in general, a big part of securing Kubernetes on OpenStack is going to be the operations piece. So there are a few questions that you should ask yourself. And again, there are a million questions that you should ask yourself, but here are kind of the basics. Who has access to what cluster and why? So when you create a cluster, when you're running a few VMs that have Kubernetes on top of it, who has access to those clusters, or who has access to those VMs rather, and why do they need access? Is the network secure? So you have a few different options when you're choosing network configurations in the network framework that's running inside of Kubernetes on OpenStack. Which one is going to be ultimately better from a security perspective? Next, you have RBAC. So from an authentication standpoint, somebody can get into the Kubernetes cluster, but what do they have access to once they're in there from an authorization standpoint? And what network you're going to ultimately use for your Kubernetes cluster. So first things first, cluster management. And we kind of talked about this already, but who has access to what servers from an SSH standpoint? So let's say you have, some type of multi-tenancy, right? So you got a few clusters and everybody on the dev and ops team has access to them. Well, when they SSH into the cluster, what do they actually have access to? If they have a kube config sitting on their local host and they're accessing Kubernetes from that perspective using the API and a command line tool like kubectl, what do they have access to? If you're running a single tenant where, maybe every engineer almost has their own Kubernetes cluster for maybe development, what do they have access to? Do they have full-blown admin access, or do they only have access to certain things? Another huge thing, and this is where, like a service mesh, for example, can come into play, is communication between pods and the VMs. So pod to pod communication, for example, east-west traffic, that's all unencrypted. And those pods, obviously, that are running on the worker nodes are going to have a little bit of access to the OpenStack VMs because that's where they're running. So what access and what communication is needed there? Now, another big piece here is, do the pods need access to the API server, so the control plane? 9 times out of 10, pods typically don't need access to the API server. So that's something else that you have to think about from a cluster management standpoint. Now, from an API management perspective, if you're familiar with Kubernetes already, really all Kubernetes is an API. Anytime that you interact with Kubernetes, you're interacting with an API. So if you run kubectl create or kubectl apply on a Kubernetes manifest, you're doing some type of post request, some type of post API call. If you're running kubectl get pods, you're running a get request, a get API call. So everything that you're doing from a Kubernetes perspective is always API based. Now, depending on how you're deploying Kubernetes and where, meaning what operating system you're deploying Kubernetes to and what distro you're deploying it to via OpenStack, there's going to be some different defaults for the API and a different max API. So for example, using 9.4.1 for the train release, you can only go up to version 1.18, whereas version 14.0.0 Yoga, you can go up to version 1.23.3 for the Kubernetes API. So that's going to be a big thing from a security perspective because you don't want to be too many versions behind. Like version 1.18, that is several versions behind, and you should definitely think about updating or upgrading rather from not only a security perspective, but from a features and reliability perspective. That's a very old version of the Kubernetes API. So thinking about API management and what distro you're going to be deploying is going to be extremely crucial. Now you also have public Kubernetes clusters and private Kubernetes clusters. Now a public Kubernetes cluster, you can essentially hit it from anywhere. So for example, if I'm on, I'm on my Mac right now and I'm not hooked up to a VPN or anything, and if I was able to reach out to a Kubernetes cluster from here, from my Mac without any VPN, that would mean the Kubernetes cluster is public. And then a private Kubernetes cluster, it's really only accessible inside of the VPC. And, if you're working from home, for example, most likely you got some type of VPN set up. Now, here's a scary fact. This was actually published on Bleeping Computer just a few days ago. So I'm recording this July 5th, and this was published June 28th. Over 900,000 Kubernetes instances found exposed online. That is absolutely insane. This article reminds me of the Shodan website when I go on there sometimes and I look at all the different Active Directory servers that have public IP addresses and they're exposed to the internet. Like, this is pretty insane. And the harsh reality is that a lot of Kubernetes servers are public because when you're using certain cloud providers, for example, by default, everything's public. There's a public IP address associated with it. And you know what? There are pros and cons. If you have proper RBAC set up and you have a public Kubernetes cluster, there's always the risk, from a security standpoint, you never just are safe. It's never about stopping all attacks. It's more about mitigating as many as possible. So if you have RBAC set up properly and all of that good stuff, somebody could maybe try to brute force your Kubernetes cluster. But from a security perspective, you're pretty set. However, a lot of people don't have proper RBAC setup. A lot of people don't set up proper Kubernetes related security. So this is a big deal. When we're talking about just OpenStack, so what OpenStack ultimately provides from a security perspective, you have multi-tier applications using the OVN ACL. So it's essentially a security group, which is essentially a firewall. So you got firewall rules that are running, they're called security groups in the cloud. And then from a load balancing standpoint, you have the Octavia OVN driver. Now, since we're talking about security, we all know that a lot of security starts with networking. So from a container network interface or a CNI perspective, OpenStack, as of right now, supports two CNIs. Calico, which is way more focused on security workflows and those security solutions for containers. So if security is big on your mind, Calico is pretty solid network framework from a Kubernetes standpoint. And then there's also Flannel. So Flannel is like out of the box networking. It's easy to set up. If you don't have a network engineering or network administration background, this might be a little bit easier for you. But from a security perspective, I do always recommend going with something like Calico because it is more focused on security, a little bit more difficult to set up, but that's okay. Now, the final piece here before we move over to the OpenStack UI running on OpenMetal, we're going to talk about the container registry. So as we know, to orchestrate containers inside of Kubernetes, we need those container images. We need to be able to deploy those containers. So a big piece is the container registry. Where are you pulling your container images from? And how are they running in OpenStack? So let's head over to the portal really quick. All right, so I'm on the OpenStack UI, and this is again running on OpenMetal. And I have a few cluster templates here, and I'm just gonna click on the one called K8s test, and I'm gonna click update. Now we will have videos coming out around setting up all these cluster templates using Magnum, but for now, I just wanna show, a few security related features. Now, number one, as you can see with the template, I have an option here to ensure that where the cluster is. Is it public? Can I disable or enable TLS? Then I have to worry about certificates, registry, etc. From a node spec perspective, I can include an insecure registry. Now, should you? No, but of course there are always exceptions to the rule. From a networking perspective, I can choose what network driver I want. So for example, Calico. And then from here, I can choose the network ID where it's coming from, the fixed private network. If I want my worker nodes to have floating IPs so I can SSH into them, and then where DNS is coming from. So as you can see here, I just have 8888, which is just Google's DNS for testing purposes. And then from a labels perspective, notice here how I have a cube tag. Now again, when we go over the cluster creation with Magnum, I'm going to show all of this, but this is a good one here. So kubetag, this is actually telling the cluster template, hey, I want to use Kubernetes API version 1.23.3 versus just letting the default happen, and that could be a really old version. So if you're looking to set up security from an OpenStack Kubernetes perspective, these tips here are a great place to start. Thank you for watching.